we're talking about density. So this is the two graphs that you guys made during your density lab. So what we really were looking at were the mass of water versus the volume of water that we added to the beaker. And then we also had the wood blocks. So we took the volume of the wood blocks and we saw what mass those were as well. And then we plotted them out and we saw these two different relationships. So these obviously they give us our line equations if we graph it and then label by our line. And then we also get to see them kind of compared together. So what can you start to see about these two things? Well, at 20 milliliters, I have a lot more mass of water than I do this wood. At 40 milliliters, I have a lot more mass in water than I do with the wood, and so forth, because those lines are just going to continue to diverge. They're going to continue to move away from each other because this one has a much steeper slope. They're both positive, but they have a steeper slope. And so we also look at these y-intercepts, and we know that these y-intercepts are false. They're not valid because if I don't have anything to weigh, I don't have any volume. If I don't have any volume of anything, I don't have any mass. There's nothing to weigh in the first place. So what are these telling us? So density, as we talked about, was the amount of stuff in a specific area. So we looked at 1 cubic centimeter. So for water looked a lot like this, where we had some nice spacing, we had some nice movement between the particles. And so if we think about what wood would look like, it would actually look a little bit less. There would be less stuff within that area because mass is a measurement of stuff and how much of stuff we have in a particular area. So it would make sense that this, if I had 2 of these, would weigh more than this. If I had 4 of these, it would still weigh less than this. So that's what we're trying to look at, the relationship between these two things. And that's what's related to the slope. So if you were to imagine, let's say we have metal, and we know that metal sinks in water. So what would that line look like? Would it look steeper up this way? Would it look in the middle or here? Now remember, metal sinks. So we can start to think that it's even more packed. And that's why it sinks. It's more dense. So remember, dense is just how much stuff we're in there. There's a lot of stuff crammed in, right? So let's start thinking about how can we find slope? How do we know what slope is? So let's take a peek. There's 2 different ways. Our first way is this. If we have the line equation, all we have to do is look at the equation and just identify slope. We're going to place that number over 1, and then we just have to find the labels. So in our case with water, right, if I use the exact slope I'm given, which is 0.59, I'm going to place that over 1. The next thing is I'm going to look at the x-axis. I'm going to look at that x-axis, which is going to give me those volume units. So if I'm over back at my graph here, the bottom, so the 1, so 0.959 over 1 cubic centimeter. Then I'm going to find out what they used for mass. The y-axis, they used grams. So I'm going to place the grams with that number up on top, so the 959. So it's 0.959 grams over 1 cubic centimeter. Let's do the same thing for the blocks. I have 0.411. I put it over 1. The 1 is attached to this cubic centimeter squared. Then I look what they did for mass. And I attach that to the top. 0.411 grams over 1 centimeter cubed. So you should end up, now this is a way to check if you did it okay. You should end up with the mass on top and the volume on the bottom. And the number on top is most likely not 1, except for water. Okay, so just use that as kind of a check just to make sure that you're doing okay with this. And then lastly, we now can use this relationship as a conversion factor. So now I can start thinking about how many grams do I have, how many cubic centimeters do I have, etc. So the other problem is, what if we don't have slope? If you don't have the slope, It's just a little different. First, you're going to identify the mass of the object, and then identify the volume, because I probably don't have a line graph. But if I do, I can use the information on it. So I can estimate if I have 20 here, and this looks just about like 19, right? So my volume would be 20, and this would be 19. Divide the two, and I'm going to get pretty close to this 0.959. So you identify the mass, then you identify the volume. You place the mass over the volume, but you have to remember, keep those units attached. Divide the mass by the volume. Place that number out front. So now you have this whole number. So place that out front and attach the units. And for an example, I put 5 grams / milliliters. So remember, for every 5 grams, I have 1 milliliter. And this can be stated, we can use this as 5 grams over 1 milliliter, or we can use 1 milliliter over 5 grams just because it's a relationship. And that's how we use it as a conversion factor. So I can start to move things around. So let's actually do this. Let's do our first one for water. Now, water, I'm going to tell you, the slope that we found was that 0.59, but it's approximately 1. So 1 gram per milliliter. So let's look at this. So if a recipe calls for 39 milliliters of water, ooh, that's what I have. So I have 39 milliliters. And how many grams should I measure? So my want category over here is grams ? And I also have density. So I have 1 gram per milliliter for water. Let's keep that because you might have more than one day, right? So let's use what we have. So I have 39 milliliters. I never put my conversion factor out front. Never, ever, ever. I'm going to talk about that and always kind of mention that. Then I'm going to place my conversion factor in here. Now, what do I have to do? I know I have to cancel out those milliliters and end up with grams. And that's indicating how I should set this up. So my 1 to my 1 gram. And milliliter doesn't have a number attached, so it's 1. And then we put this in. And if I were to put this in a calculator, 1 times 39, we know what that is, right? Over 1. So the milliliters, though, are going to cancel. And I'm going to be left with 39 grams. So I need 39 grams of water. Now let's try this again, but with a little bit of a challenging one. So we have wood blocks now. So if I have a wood stove with a weight limit of 40 grams, I can't put more than 40 grams of logs in this wood stove. So I have so you can do this if you like. I like to set this up just to make sure that I have what I want. So I have a 40 gram, we'll say weight limit, right? And then what volume of wood can I not exceed? So I want to know what volume I need. And I also have density here. So I have the 0.411 grams per milliliter. Now, we have all of this information. And remember, this could also be 0.411 grams per cubic centimeter. These milliliter and cubic centimeter, we found out in our last unit that they're interchangeable. I can just change the units there, and that's fine. So let's figure out what we need. I have a 40 gram weight limit. Now, I know I need to cancel out grams, so that's got to go on the bottom. I'm going to be left with cubic centimeters. We're just going to use those for sake of a solid volume. And we're going to figure out how to set this up. So my 0.411 grams, so for every 0.411 grams, I have 1 milliliter. Or for every 0.411 grams, I have 1 cubic centimeter squared. So for every 0.411 grams, remember those are attached, I have 1 cubic centimeter. So it's 40 divided by 0.411. So I'm going to toss this into my calculator here. So 40 times 1 times everything on the top, divided by 1, divide everything on the bottom, divided by 0.411 equals. And we get 97 point, and I'm just going to round this off to 32. just to make our lives a little bit easier. And what units should this be in? I wanted volume, so they should have my volume units. But did these cancel out? Those canceled out. I'm left with this. So I have my centimeters cubed. And that's my volume. So really what we have to start doing is thinking about density as a useful tool. It's a useful tool to convert things from grams to volume, or from volume to grams. And that's what I use it for generally. If I were to just define it, it's mass over volume equals density. And that's what we're going to use it for. That's how we define it in class. And it's really just the amount of stuff in a particular space, like we showed with the sticky notes in the beginning. All right, everybody, have a great day. If you have questions, please shoot me an email.